There are three ways to prove triangles similar. Yesterday we covered the angle-angle similarity postulate, which says that if two triangles have two pairs of corresponding congruent angles, then those two triangles will be similar. The next way to prove triangles similar is the side-side-side similarity theorem. It states if the corresponding sides of two triangles are proportional, then the two triangles are similar. It's similar to the side-side-side congruence theorem, except for instead of the sides being congruent, the sides just need to be proportional. And finally, the side-angle-side similarity theorem. If we have two pairs of corresponding sides that are proportional, and the included angle between those two pairs of corresponding proportional sides, then the two triangles are similar. Let's look at some examples. Example number 1. We have parallel lines, and we have a transversal that cuts those parallel lines. So we really have two triangles in this picture. This smaller triangle and this bigger triangle. Now if we look, this triangle and this bigger triangle both share this angle. So we have a pair of congruent angles because these two angles are the same angle. They're reflexive. And since we have parallel lines, this angle will be congruent to this angle. These two angles are corresponding, which means that they are congruent. And we kind of already know this, that these two triangles are congruent by the angle-angle similarity postulate. But we have another pair of corresponding angles that are congruent. We don't necessarily need those two angles, but they're there. Let's look at example 2. I'm going to redraw the two triangles again. So I have my smaller triangle and my bigger triangle. Now I don't know if these lines are parallel, so I can't assume that I have corresponding angles that are congruent. They might be, but I can't just assume it. Just because two angles are corresponding does not necessarily guarantee that they're congruent. I do have a pair of shared angles between these two triangles. So by the reflexive property, these two angles will be congruent. Now if I label this small triangle, this side is 10 and this side is 6, and this side will be 9, which is 6 and 3, and this side will be 15, which is 10 and 5. So I want to check to see if these sides are proportional. To check to see if the sides are proportional, set up a proportion. I'm going to relate 6 to 10. And I'm going to relate 9 to 15. To check this proportion, cross multiply. Six times 15 is 90. And 10 times 9 is 90. So yes, these sides are proportional. So this side is proportional to this side, as this side is proportional to this side. So how are these triangles similar to each other? Side, angle, side, similarity postulate. Similarity theorem. Let's look at example 3. In example 3, we have all the sides of these two triangles, and we know nothing about the angles. So we need to decide if these sides are proportional. Now what's tough is we don't know what sides to relate to each other. Does this 8 go with this 9 because they're both on this part of the triangle, or does this 8 go with another side? To figure out which sides to relate to each other, we need to rank the sides as shortest side, the longest side, and the middle side. If I look at this first triangle, 8 is the shortest side. And the shortest side of this triangle is 6. So the two parts that I want to relate are 8 and 6. And now I want to relate my longest sides. The longest side of this triangle is 16. And the longest side of this triangle is 12. The middle side of this triangle is 12. And the middle side of this triangle is 9. Now I need to reduce these ratios. 8 over 6, both are even, so they can both be divided by 2, reduces down to 4/3. 12 and 9 are both divisible by 3. So it reduces down to 4/3. And 16 and 12 are both divisible by 4. So 16/12 reduces down to 4/3. If we look, we have the same ratio between all the sides, which means that these two triangles are proportional to each other. The shortest sides, 8 and 6, are proportional. The middle sides, 12 and 9, are proportional. And the longest sides, 16 and 12, are proportional. So even though these two triangles aren't drawn to scale, and it's tough to tell by just looking at them, we can rely on math and ranking the sides to figure out if they're proportional, to figure out if these two triangles are similar. In this case, the triangles are similar by side, side, side similarity theorem. And the last example. We do have parallel segments, which means we do have congruent angles. And these two triangles share an angle. So I really have this triangle and this bigger triangle. And these two triangles will be congruent by the angle-angle similarity postulate. So how do I solve for x in this problem? Well, this side is 15, and this side is x. And this side is 15 and 24 long, so it is 39. And now this side is x and 16 long. A lot of students want to write down 16x. Well, that means 16 times x. To find out this entire length, I don't want to take 16 times x. I want to take x and 16 and add them. Now, since these triangles are similar by the angle-angle similarity postulate, the sides will be proportional. So set up a proportion. A fraction equaling a fraction. Now I'm going to relate 15 to 39 and x to x plus 16. Now I need to cross multiply. Drop down my equal sign, and I'm going to have 15 times x plus 16, and I need to put x plus 16 in parentheses, equals 39 times x. Now solve. To solve for x, distribute. 15x plus 240 equals 39x. Subtract 15x from both sides. 240 equals 24x. Divide by 24. X equals 10. So there are three different ways to prove triangles similar. Angle, angle, side, angle, side, and side, side, side. Once two triangles are similar, their sides are going to be proportional, which we can use to solve for variables.